Hello, everyone. In case you missed it, Shipyard's now HIPAA compliant. We're really excited because that allows us to work with healthcare organizations around the world. We know the difference that you make in your patient's life, and we can't wait to help you make that difference here at Shipyard. I thought, what better way for me to celebrate us being HIPAA compliant than to work with the healthcare data inside of a data project? So that's what we're going to do today. So inside this project, we're going to export some data from Kaggle and put it inside of Google Sheets. We're going to take that data from Google Sheets and put it inside of Shipyard. We're going to use a Python script to run a logistic regression. And then we're going to use that logistic regression model to actually predict BMI based on height and weight. So without further ado, let's dive in and work on this project. So the problem with healthcare data is that obviously no one wants to share that out. So I'm working with a data set off of Kaggle. So this is a data set that someone's uploaded. So it's not actually from anyone's actual healthcare data warehouse, but this will work exactly the same if you're working with your own data as well. So looking at this data set, it's a BMI data set, which I think BMI is body mass index. You could tell I don't care too much about that, but it's a good data set for us to work with. So just what we're working with here, it's a smaller data set, but what we're seeing here is gender, height, weight, and the BMI index. So you can see what we're going to be working with here is actually we have three variables. We have gender, height, and weight. And then, of course, we have our BMI index, which is kind of the last thing, right? And you can see the index is set as 0 is extremely weak, 1 is weak, 2 is normal, 3 overweight, 4 obese, and then 5 extremely obese. So that's our BMI index. So what we're going to do, I've already done this. You just download up here on the top right-hand corner. Kaggle does have an API. However, I didn't see the use of actually using their API here to do this one data set. If you already have that set up, that would be a good way to start. But you just go ahead and download this data set. You pull it in. I pulled it into a Google Drive here. So what you can see is, we have this BMI.csv. It's in the BMI project folder. And so if you're working with a Google Drive inside of Shipyard, what you're going to have to do is actually share that folder with us at Shipyard with a service account. And you can see I've already done that here. If I come down here, you can see, I'm sorry, I think I've shared the file, excuse me. So you can share the folder or the file. So if you have multiple things coming in, makes sense to share the folder. If it's just one thing, you can share the file. So let me do our share here. And you can see there is our service account's email there. So I've already shared that before we started the video, so I didn't want to bore you too much with too much setup stuff. But that's really the only thing you have to have set up before this is a service account with Google Drive or wherever you want to pull your data in from, whether that's Kaggle or Google Drive or wherever. So that works there. So I'm going to go and click Done. So we have that set up. And then let me pop over into Shipyard. And what we're going to do is we're going to go ahead and import this data. So importing the data here. So we're going to use our Google Drive blueprints. Okay, so download files to Shipyard. So I'm going to go ahead and click that. Download files to Shipyard because we want to pull the file in. So I'm going to say download BMI file from Google Drive. Is the name of this vessel. So this is going to allow us to download that file from Google Drive, just like I mentioned. So it's in a Google Drive folder name, excuse me. So BMI project. So that matches there. Let's see. The file name is, and again, this has to match. So BMI.csv. So BMI.csv. So that's perfect there. Excuse me. You can put it inside of a folder inside of Shipyard. The only time you'd really probably do that is if you have multiple BMIs.csvs. Excuse me. We're not going to need that, so we're just going to leave that blank. You can also rename that file after you download it if you did want it to be BMI.csv. We're going to leave that blank right now as well. It is not in a shared drive. Or am I wrong? It might be in a shared drive. No, it's not. I'm sorry. I always get folders and drives confused with Google Drive. So yeah, we're good set up there. The only thing else we need is our service account in JSON. So I'm going to use our credential to do that. So we already have that set up here. And Google application credentials, perfect. So that is set up there. So that's going to pull that file in, and it's going to download it, and it's going to allow us to use it downstream. So inside of Shipyard, we have an ephemeral file storage system here that, whenever this brings us in the first vessel, anything downstream can use that file. But as soon as this thing gets done running, it's going to delete all those files. So we do that for security. So if you bring any healthcare data in, we are HIPAA compliant, so that's fine. But if you bring any data in, we don't want to store it on all ends. And you don't want us to store it on our end either, so we delete it at the end of your run. So that's just a good safety feature for you to realize. So that's going to bring the file in, so we're good to go there. So what I want to do is I want to add in one extra step here. It's a blueprint that we have. It's just calling to see what files are in the storage here. So I'm going to put that in there just to make sure the file gets downloaded. So we connected those together based on a success. So I'm going to go ahead and save and finish this fleet. We're not done with the whole project, but we are done with importing that data. So I'm going to save and finish fleet, and then I'm going to go ahead and run it. So I'm going to run this fleet. This is going to take us to a log page. It's showing us kind of the live log as this thing is running. So you can see it's created. It's going to start running for us in just a moment. It's going to download that data for us. And then again, it's going to show us what that file system looks like inside of Shipyard. So we should be able to see that BMI.csv whenever it sits there, so that we know downstream that we can work with it, right? And that's what's really important here inside of Shipyard, is that you make sure that file comes in, and as soon as it's in, you can use it downstream. And we're going to use it with some Python vessels later on. So you can see that that bar just turned from yellow to green. That means that file has been downloaded successfully from Google Drive. So since that's been downloaded successfully from Google Drive, it's going to move on to do that bash script to list all files. You can see that's done there. And you can see there is that BMI.csv. So that data has been pulled in from Google Drive. That means that we're ready to go downstream. So that is going to be it for part one of this video. So that was just importing our data and giving a little bit of an overview of what we're going to do. In part two, we are going to actually clean up that data a little bit. We need to actually change the gender from text, and we need to kind of ID that from 0 to 1, and a few other things. So we're going to clean up that data, and then we're going to go ahead and build that model inside of step 2. So make sure you move on into step 2 if you're interested in following along, and we hope to see you there. So picking up right where we left off in the last episode, so we had our Google Drive vessel, and then we had the list all files vessel. So the list all files vessel was just so we knew that file was inside of the ephemeral file storage system. So we're going to go ahead and delete that. So what we're going to do now is we're going to add a Python code vessel in the Shipyard. So it's a little bit different than the low code blueprint that I used before. So this is where we can use our actual code to make this run. Excuse me. So I'm going to go ahead and connect those together based on the success, because we don't want this to run unless that file gets downloaded. And then we're going to do BMI model.py. So we're just going to call that BMI model.py. So if you're working inside a Shipyard, not in this project, but just say you're working inside a Shipyard, you can actually connect this to GitHub and run your code that way as well. So you don't have to actually write your code inside of the platform, but that's what I'm going to do in this example here. So starting off, I feel like the most important Python code you can write is to import pandas as PD. One of probably the most used lines of code in Python is using pandas, so that's definitely there. We want to go ahead and we want to read this in as df. So df is equal to pt dot read csv dot, and then our file name is bmi.csv. Okay, so it's going to read that in as a data frame. I'm not going to go through like at the nitty gritty parts of this Python code, so hopefully you can follow along with me. But it's going to read that thing in as a data frame. So whenever you're writing out a machine learning model, you probably want to do a lot of like visualizations to test your data out. This is coming from Kaggle. The data from Kaggle is generally more pretty than just like raw data coming from your system. So like this data is already pretty for us. We just got to do a little bit of cleanup to change some things that have to work inside of our model. So we're going to get away with some of the cleaning steps, just to be honest with you. But if you're doing this in a production environment inside of your own data, you're probably going to have to do some cleaning steps with the Python or SQL inside of your database. So just a little preface there. Let's move on. So reading in that as a data frame. So the first thing that we want to do is, models don't do well with text-based columns. Like we have our gender, which is male and female. Not really what we're looking for there, right? We want to map those out to be numbers. So we're going to go ahead and map those out. So what we're going to do is we're going to change our df of gender. So we're going to change our gender column to be the gender column that was there. I don't know why I keep looking at my keyboard. It's like I don't know how to type. It's fine. We'll figure it out. And we want to map it. So we're going to do a map function. So it's going to map that based on, we're going to say the male is 1. Male is 1. And then female is the first number, which in Python, which is 0. Okay, that's good. That's great there. So it's going to remap that column. Instead of having male and female, it's going to have 0s and 1s. So it's going to work out there. So we can go ahead and move on down, and we can test that inside of Shipyard as well. I'm not going to show this after every step, but to test, we can print that out now. We can print out df.head. Just go ahead and print the head of that out. To do that, we'll go ahead and save our fleet, and then we'll run it. So inside of Shipyard, it's going to download that file from Google Drive. It's going to do that map, and it's going to print the head of that data frame. So I'm just going to go ahead and show that off just to make sure that everything's running like we want it to. This is not going to run because we forgot one important step inside of Shipyard, and that's that we have to install our packages. So we have pandas, and I have a PD0 there, which is not great. So we have to install pandas down here in our Python packages. So we're going to go ahead and put pandas in there. We leave the version blank because we'll just install the most recent version of pandas that works. So you can see, even me that uses Shipyard on a daily basis, sometimes we still make mistakes. So go ahead and resave that. We're going to go ahead and run now. So it's going to rerun this again. So remember, it's going to download the data from Google Drive, and then it's going to map that gender column to be 0 and 1s instead of male and female. So this is going to kick off and run in just a moment here. So you can see it's already turned green there, so it has downloaded it. So it's executing this Python script, which is going to, again, read that in and then map it out. So we grab a drink while that's running here. So we got a yellow play mark. That means it's currently running. There we go. It just finished successfully. Go ahead and click in there. So you can see now the gender column is 1s and 0s instead of males and females. So our mapping worked just like we expected it to. So we can go ahead and move on now. So go back to our fleet builder. We're going to edit this code that we have here, and we're going to keep rolling down with it, right? So we map that in. That's great. So now what we want to do is actually start training our model. So we're going to do from sklearn.model selection. We're going to import train test split. So remember, we only have this one data set that's around 500 values. So we need to split that into some training and some testing data just to make sure that our model is working as we want. So that's what's going to work there. So now we're going to define our features and our target variable. So our features are what we had before, which was our gender, our weight, and our height. And then the target variable is going to be that BMI index. So let's define that. So X is df, double brackets. That's gender, height, and weight there. Okay, that's perfect. So that is our features. And then our Y variable is our target, and that is the index, which is that BMI index, again, 0 to 5. 1 to 5. 0 to 5. No, it's 0 to 5. Okay, cool. Anyways, it's fine. Okay. So now we're going to split this thing up. So we're going to split this up into testing and training data. So we're going to do a X train. Sounds like a WWE wrestler. We're going to do an X test. If I can type, we're going to do a Y train and a Y test. And that's going to be a train test. We're calling that function train test split that we imported up here. And we want our X, we want our Y as the two variables. We want to do our test size. We're going to do that to be 20%. That's pretty normal, 20% of the data being tests. And then random state, we're just going to start off with 42 because 42 is the best number. Okay, moving on. All right. So we're good to go there. Generally, you want to see like what size those things are, but with some simple math, we can figure that thing out. So our training data is going to be 400 values, and then our testing is going to be the 100 that are left. So 400 to 100 is going to work out well for us. So moving on down our code. So now we actually want to like build this thing out. So we're going to import some more stuff. So from sklearn.linear model, we want to import, if I can spell, import logistic regression. So that's perfect. And then from sklearn.metrics, we want to import accuracy score because we want to obviously know how our model's doing. So import accuracy score, perfect. So we got our data trained up. Let's continue on here. So we can do our logistic regression model. We're going to call logistic regression there. We're going to start off with a max iteration of 1,000. And again, we're going to use that random state of 42 just to be consistent. So that's perfect there. So it's going to build that logistic regression model. We're going to do a fit. We're going to fit that on the training model that we built out earlier. So xtrain. Man, I am struggling to type today. It's fine. Xtrain and ytrain. So that's perfect there. So we're fitting that model. And then we're going to do a y prediction. So we're going to use that to predict. So we'll do logreg.predict here. And we're predicting with the x test data. So perfect there. And what we're going to do is calculate the accuracy using accuracy is equal to accuracy score. So we're going to call that from earlier. And that's going to be, we're going to toss in the y test with y predict just to get a score. And then we're going to print out the accuracy. All right, so I kind of went quickly through that. So let's talk about what we're doing here. So we split the data into testing and training. We're building out that model with 1,000 iterations max, 42 random state. We're going to fit the model using the training data. We're then going to predict using the test data, get that value, and then we're going to test that with the accuracy score there. So it's going to work out. We're going to print out our accuracy. So we're going to rerun this thing again, and we're going to print out that accuracy to see where we're at. So let's do that. So save our fleet. We're going to click run now again, and we're going to kick this thing off and see what happens. So let's do that real quick. So again, we're going to bring in that data again from Google Drive, and then we're going to run it there, right? So a question that usually comes up in our demos, well, Steven, is there any way to save a file to use later on? And in Shipyard, currently, there's not a way, because again, we do not want to save your files at Shipyard just for security reasons. We'd rather you have your data on your databases and then your cloud storage systems and just bring it into ours whenever you're ready for it, right? So we're going to bring that down again. So you can see it happens pretty quick, happening in around 10 seconds there. Then we're going to go ahead and execute that Python script. So this is going to take a bit longer this time because we're doing a bit more stuff than we were, but still shouldn't be too painful. And you know what we forgot to do again? We forgot to import scikit-learn. So let's see how many times I can do that in this video. So we're going to go install scikit-learn. If I had $1 for every time that I have forgot to install a package, just across the board, not just in Shipyard, but also just in general, just forgot to install packages, boy, I might never have to work again. I wouldn't be making YouTube videos anymore. I would just keep making mistakes. So yeah, we're going to kick this thing off to run it again. So no harm, no foul there. Just make sure you install those packages. And again, best practices out of Shipyard is once you get code that's written in production, put that in the GitHub. If you have a requirements.txt file inside of GitHub, we're going to automatically install those packages for you. You don't have to type anything into our platform. We're going to parse that requirements.txt file for you and install those packages so that you don't have to make the same mistake that I keep making, which is great. So we might even call that the Steven rule there. So the cool thing about Shipyard is you can actually click inside of these bars, and it's going to show you the actual Python output from these runs. So if I click inside of this bar, you're going to see the accuracy score is 83%. We're not changing the world with that accuracy, but pretty good. But I think we can do better. And if we scale this data up, we can probably do better with some accuracy. So let's test and see what that would look like. So let's go back to our fleet builder. We're going to edit this script again. We're going to want to pull in. The scalar information from scikit-learn. Scikit-learn.preprocessing, and we're going to import standard scalar. So that's going to just standardize scalar there just to help us out with our models. So we're just going to call that. So we pull up down here. So I'll leave that for right now. So our scalar is equal to standard scalar. Perfect. So we'll do x train scaled. We'll call this variable, and we're going to do the scalar dot fit transform x train, and then we will do the x test scaled and do the same thing. Scalar dot transform, and that's for x test. There we go. Perfect. So let's see. So then we're going to retrain the logistic regressing model based on the training data. So we're going to do our log reg scaled is equal to logistic regression, and then we're going to do the same thing. So max iteration to be equal to 1,000, and then the random state of 42 again, just so we can keep everything on the even playing field. And then we're going to do our log reg scaled, and we're going to fit this model with x trained scaled, comma y train. So we're going to fit it based on that new scaled data. Then we're going to predict off of that. So we're going to do a y prediction scaled. It's going to be equal to log reg scaled dot predict, and that's going to be off of the X test scaled data there. And then now we're going to do our scaled accuracy and see what happens here. So accuracy scaled, and it's going to be accuracy score. So we're calling that same function before. We're going to do Y test, and we're going to do it on the Y pred scale there. So perfect. So that's going to get that value there. And so then what we're going to do, so we're going to come back up here to the top. So we're going to do, we're going to make this into an F string here. So print F. Before scaling, the accuracy, if I can spell, is that. And then going to be lazy, copy and paste that down there. So then after scaling, the accuracy is accuracy scaled. Perfect. So I'm going to go ahead and save this. Going to go ahead and kick this thing off again. This is going to, again, going to rerun all that again, but this is a pretty small model. We're not doing anything crazy here. So I'm going to rerun this. Remember, it's going to download the data from Google Drive again, run through this code one more time. We're going to get our accuracy scores. My hypothesis is this should make it better. If not, we'll just go with the first model that we trained. But I think this is going to be a better prediction based on the research I've done beforehand. So while this runs, let me grab a drink. Okay, perfect. So we've downloaded the file from Google Drive. The Python script has started executing now. It's running. Hasn't failed yet because we still use scikit-learn there, so we didn't have to import any new packages. So Steven didn't break it again, which is spectacular. Oh, but it did error out. Aha. But it turns out you do need to end your F strings with quotation marks. For both of them. All right, perfect. Gonna go ahead and save it. Kick it off again. It's the world of Python coding had to get me somehow. It couldn't get me on packages again, but it couldn't get me on quotation marks. So I'm not gonna make you watch through this full run again. So we'll jump back in as soon as this thing gets done running. Boy, am I glad this is not live because we did get another error. Turns out you spell the word scalar with an ER instead of an AR, and then transform is tough to spell somehow. I don't know. It's fine. Moving on. We got 2 green bars here. That means that we're successful. So we can go ahead and look at the logs here. We can see what we got. So you can see before scaling, the accuracy was 83%. After scaling, the accuracy is 92%. 92% on a logistic regression model is pretty good. So we're going to roll off with that. So what we want to do to get this thing ready to move on from part 2 into part 3 is we want to export these models. So whenever we export this models, that allows us to use it in another vessel, which is important. That's what we're going to do next. However, it also allows us to take this into like Google Drive or something like that. So that, your colleagues can use this model or someone else can use this model later on as well. So really important steps. We're going to jump back into the Fleet Builder one more time here. And we're going to import a new package. So I'm going to remember to install it this time. So we're going to say from job lib import dump. Okay, there we go. Let me scroll down to the bottom here. So we're going to dump the log reg scaled model, and we're going to save it as log reg model. Well, let me not be lazy because people want to read it. So logistic regression model, and the abbreviation is joblib. And then we want to do the same thing for our scalar as well, because we reuse it. We're going to need to scale as well. So we're going to dump the scalar, and we're going to do scalar. Sorry, we're going to name this scalar dot joblib. And then just so we can have some visibility on this thing running, we're going to say we're going to f string. So the model is saved to we'll say to this, and We're going to print. Nah, we don't care about that. So let's print out the model is saved. Yeah, we do. It's not very lazy. So we're going to print out both of them. So we're going to print that the scalar is saved to scalar.joblib. So again, this is one of those things that you see whenever you're working with Steven. It's like, well, I don't need to save that. I don't need to write that down. And you come back to it a week or a month or a year later, and you're like, oh, I'm glad I wrote that down. So print those two things out. We're going to save those in. And then just to make sure we have everything working, first off, we're going to import this package, or else I'm going to forget. So we're going to import joblib just to make sure that it's working. Perfect. There we go. So then what we're going to do is we're going to do that step that we did in part 1 where we're going to list all the files. So it's going to show us bmi.csv and those 2 joblib files so that we know that we're ready to move on into part 3. Going to save this, going to kick it off again. Once this one finishes, we should be ready to move into part 3, barring any errors. So let's give this thing a kick off, see what happens here. So remember, we've done our model, we've then scaled up, we've created a new model, tested both of them. Accuracy was better on the scaled one. We're taking the scaled one and saving it so that we can pull that into part 3 and actually do some predictions on it, which is going to be really fun. So you see that we downloaded the file from Google Drive already. Next is going to open up our Python script. Hopefully everything is going to import this time. Again, like it's the curse of Steven, I feel like, that something's not going to import. So hopefully not this time. Generally, if it gets past the first like 9 or 10 seconds, you're usually in pretty good shape because that's how long it sometimes takes to install some packages. So we look like we're good to go here. Just making sure everything loads through. We got green bars, so we can actually click into this and see what's going on. Everything's saved. There's our accuracies. Looks pretty good. So then we should get our last vessel to kick off, which is a list all files vessel. So it should just kick off in just a moment here, and then we're gonna be able to see all those files listed. So we open this up. You can see there is our model joblib, our scalar joblib. There's that bmi.csv. Got everything that we want here. So just kind of recapping what we've done in part 2. We've actually, wrote out this model, made it a bit better with some scaling, and we've exported that model so that in part 3, when we open up part 3, we can open up that model in a different vessel to make it a little bit more simple, and we can do some predictions. We can even create a blueprint to create the predictions, which I think is going to be really fun. So that's what we're going to get into in part 3. So I hope to see you there. So diving right back into Shipyard here, I want to show off what we've built so far. So we download our BMI CSV file from Google Drive. We execute a Python script to build that machine learning model. And remember, we save that as logistic regression model.joblib and scalar.joblib for the scalar. So we're going to use those in the next vessel to actually make some predictions on this data or on this model using some prediction data. So the cool thing about Shipyard is that since we've saved those, we can use them anywhere downstream. So we could create another Python vessel like you see here, but what we're going to do is we're actually going to create a blueprint. The reason we're going to create a blueprint is because it allows the user a much better experience of actually predicting. It's going to give them a nicer input screen over here on the left side. You'll see that in just a moment. So let's jump over to our blueprints, and we're going to create this. So I've already selected our Python language here. So we need to create our variables. So in our variables, we're going to need, if you remember back from our variables in the model, we had gender, we have height, we have weight. So that's what we want to create for our variables here. So starting off with display name, we're going to have gender. Reference name, we'll just do lowercase gender there. It is required. We won't have a default value. We'll just leave placeholder and tooltip blank for right now. So that's going to work. So we're going to reference this in the code with gender. Okay, so that's really important. So add variable there. And so now we have height. So we're going to put height, and then that's in centimeters. So reference name, we'll just call this height. Again, that's how we'll reference it in the code. This should be an integer, and it is required. Okay, so that's perfect. So that's height, and then we need weight as well. So we're going to have weight, and that's in kilograms here because that's what is used in the it's what's used in the data set from Kaggle. Make that lowercase to match. So we're going to say that's weight. This is going to be an integer. So again, you could make this be a float as well if you wanted to. If you wanted a lot of people to put some decimals in there, I'm not that worried about that for this. So we're going to add that variable. I think that's all we're going to need. Yeah, so that we just had those two. Okay, so I think that's perfect. So that's great. So we're going to move on to the next step, and this is going to be where we actually do our code. Okay, so we're going to call this predict.py. Okay, so we're going to import our thing. So we're going to say from JobLib, we're going to import load. So it's going to allow us to load those models and the scalar that we used prior. We're going to import NumPy as MP because we're going to use that later as well. And then we're going to import sklearn. Okay, so our import sklearn, working with machine learning models, probably a good idea there. Okay, cool. So the first thing we're going to do is actually load this model. So we're going to do model is equal to, we're going to do load, which is that JobLib function, and that was going to be what we called it before. So logistic regression model dot JobLib. Okay, so it's going to load that model. Again, this could be a variable if you wanted it to be as well. If you wanted this to be a little bit more abstract, you could make the model name a variable. We don't need to do that right now. So next, we're going to load that scalar in as well. So scalar, I had an error where I misspelled scalar earlier, so I'm not going to do that again. So load, and that's going to be scalar.joblib as well. Okay, so now we have our model and scalar that we can use now in this code. So now we're going to get our actual variables that we just pulled in. So we're going to use OS to do that. So I'm going to import OS. So essentially those variables we created earlier are kind of like environment variables inside of Shipyard. So we got to go out and grab those. So we're going to do gender is equal to os.environ. Make sure I get that right. Environ gets. And remember we called that just straight gender. So that's perfect there. So that works. And then we have our height is going to be equal to, I'm going to be lazy and just copy and paste that there. So that was just height. These are numbers, so this is we always read in our environment variables in Shipyard as strings. So I'm going to go ahead and wrap that in an int, so it can be read in as an integer. And then we have our weight is equal to, again, same thing. Going to copy, paste that there. Weight. Okay, so again, we're going to change it to an integer to be used in our function, but that's going to grab our gender, height, and weight from those inputs that we set up earlier. So you're going to see what those look like in just a moment. It should be pretty cool there. Then we need to convert our gender to numbers like we did before. So we're going to do gender, if I can spell, gender numeric is equal to 1 if gender is equal to male, else 0. Okay, so that works there. You could be a little bit more abstract in this code, like try to make sure that, you know, if they put male, uppercase, lowercase, they could put boy, girl. So you could be, get some more ifs there and abstract a bit more, but we'll just leave it simple because we're the ones who typing this in, right? So male and female, so that works. And then we need to do our input features and put them into a NumPy array. So our input features are equal to a NumPy array. And that is, we're going to open up parentheses, open up double brackets. So that's gender numeric, which we just created. That's going to be height, and that's going to be weight. That's perfect there. And then we need to scale these. Remember, once we scaled, we got a better accuracy when we create this model. So we need to make sure that scale is uniform across these, across this prediction as well. So input features scaled is equal to scalar dot transform, and we're going to transform those input features that we just did. So that's perfect. So that's going to do that, and then we're going to make our prediction. So we're going to do a predicted index, is equal to model dot predict, and that's going to be our input features that we just scaled there. I'm sorry, input features. That would have been sad if I forgot to do the scaled version. So that's great there. So it's going to do our model prediction, and then we can just print out the solutions here, right? So print. So we're going to f string. So the predicted index is the predicted index. You can spell. So the first value of that, which is going to give us that value. So that's what we used earlier when we did that. So that's perfect. I should probably close my string there. So that's all we're going to need to actually predict that, right? So it's going to allow us to use the model and the scalar that we generated earlier. That's perfect there. We got our predict.py. So now we need to make sure that we install the right packages. So for our Python packages here, we have our JobLib, we have NumPy, there we go, and then we have scikit-learn. I always forget that one. There we go. Make sure I got the hyphen in right. So scikit-learn. There we go. That's perfect. So now we can go and name this thing. So that we'll do predict BMI. This blueprint will take in a ML model and predict BMI index. Perfect. So we'll go ahead and throw the word index in the title. Put a space so it's readable. There we go. Okay, and we're not worried about the guardrails there. So we're going to go ahead and click save and finish. So that's created now. So we can use it in a fleet, but we already have a fleet. So we're going to come back in here. We're going to give this the old refresh. And that blueprint should pop up for us here so we can go ahead and use it. And you'll see in just a moment why I chose to go on the blueprint route versus actually just hard coding that in there. So we called that predict BMI index. Perfect. So we have that. So we can go ahead and connect that together based on a success there. And you can see our gender, height, and weight. So we can go ahead and throw a male. I don't know let's see. I am 5 foot 8 inches in centimeters. What is that? 173. I'm just so tall. My height in centimeters makes me sound way taller than I actually am, and I appreciate that. So that's 173. And then I weigh around 195 pounds to kilograms there. So that is 88. So 88 will round down since it's not at the 5. So 88 kilograms. So throw that in there. I'm sure this is going to give me a bad BMI index, but that's fine. So I can go ahead and click Save Fleet. So this is going to save that last piece of the puzzle in there. And then we're going to go ahead and run it. And that's going to allow us to see what that BMI index is. So go ahead and click Run now. It's going to kick it off. So remember, it's going to go through. It's going to grab that BMI.csv from Google Drive. It's going to create our model with that second vessel. And then the third vessel here is going to actually predict my BMI index based on the information that I put in. So it shouldn't take too long to run. We're not doing anything super crazy, but we'll wait just a second for this to finish up running. I used to be a math teacher. Like, I should know my pounds to kilograms and my feet, my feet in inches to centimeters. But, is that stuff actually important? We have Google. It's great. Oh, goodness. So you can see our BMI file has been downloaded from Google Drive. Our models are now done. So now the moment of truth. So our prediction should now start in just a moment here. And then we're going to see what that BMI index is, and hopefully this is all going to work. And you can see the list all files ran first. So if I click on that, we can go back in there and just make sure there's a BMI.csv, there's our logistic regression model.joblib, and there's our scalar.joblib. So everything looks good there. So our fourth vessel should start in just a moment here to allow us to see those predictions. So we'll just wait for a moment for it to start. Okay, so you can see that prediction is over and complete and successful. So the moment of truth, let's click in here and make sure that everything ran successfully. So if I click into that, you can see there's a predicted index of 3. So worked out pretty well. So what we're going to do is we're going to go back in, change up some numbers to make sure that things are running. So let's say I change that kilogram to, oh boy, if I change that kilogram to, what if I change it to 100? What is that in pounds? Let's go up a little bit more. Let's go like 110. There we go. So should get a different BMI index there. So we're going to rerun this one more time, and just to make sure that, it's not just going to give us 3 every time, because that wouldn't be what we want. So let me resave this. We're going to rerun one more time, and we'll see what that index looks like. So going to go and kick it off. Not going to make you watch this full thing run again. So we'll be back as soon as this thing finishes up. All right, so jumping back in, the second run finished up. We can click in here and see our results. So you can see that predicted index going up to a 4. So it looks like things are working like we expect them to. So it looks like it is making good predictions there. So yeah, that marks the end of this project. So we kind of went end to end. We took that data in from Google Drive as a CSV from Kaggle. We built that logistic regression model, tuned it a little bit with some scaling, but nothing too crazy. And then we created some predictions using a blueprint. So it's kind of the end of this project. So this is how you would build a machine learning model inside of Shipyard. But this process would work anywhere you want to work with it, right? So on a notebook, just any coding editor. So it's going to work anywhere, but I think it works really great inside of Shipyard. So there is going to be one bonus piece to go in with this series where I'm actually going to show you how you can use our API to actually make these predictions through our API calls. which should be a really cool kind of addition to the series. I don't want to include it in the series because it's not really relevant to building the machine learning model, but I think it is a cool add-in. So be looking out for that pretty soon.